Hello everyone, I'm Michael Wagner, and I was part of the design simulation team for the 491 Capstone. Uh, so as part of the design simulation team, I chose to look at computational fluid dynamics. So I downloaded Autodesk CFD 2021 and got it familiar with the program. And so this is kind of a walkthrough of the results and kind of how I collected data for our project. So this is what you're presented with when you finish a run in Autodesk CFD. This is the global pressure view of the simulation. So if we rotate, you can see we have a nice uniform orange color here, which is the velocity indicated in color. You can see the scale here. Kind of gives you an idea of what the colors mean. So if we rotate it to the back side of the wind tunnel, we can see that there's obviously something inside the wind tunnel that's changing the velocity of the flow exiting. So what we need to do is get rid of all this blocking our view of the model. So to do that, we just go with an outline. So now we can see that our model's here in the middle of the wind tunnel. Wind tunnel is quite a bit bigger than the aircraft, but it works. So our model, and then we have this small bulkhead. We can't figure out what's going on with the 3D model imported into Autodesk, but the skip file, when we open it, there isn't this feature, but when we import it into Autodesk, it automatically shows up. So we're unable to figure out how to get rid of that for the project. However, to minimize its impact on all of our calculations, the material type for the volume has been set to air, so it's literally a volume of air inside of a volume of air, so its impact to the simulation is minimized. So first we need to take a look at the velocity, the airspeed variations relative to the backside of the aircraft, because we're deploying a sensor and we need to understand how far that sensor needs to be based on airspeed so that it's as stable as possible. So to do that, we're going to reset the view to the front, and we're going to come up here to plane and add. So right now there's a plane that's parallel to the y-axis. We need to change that to be parallel to the x-axis. So we're going to go to the top view, and we're going to use this arc to swing it around and line it up parallel to the x-axis. So we're a little bit off. So fine tune it, and it looks like it's going down straight down the middle of the aircraft. So we're going to go back to our front view, and we can see that there's obviously changes in airspeed, which would be relative to changes in pressure. So to get an idea of how far the sensor would need to be deployed, what we went for is looking to minimize the change of airspeed. So we're going to look at where we're starting to get into this yellow to orange pattern behind the aircraft, and we are lucky enough that we have a nice little measuring ruler right here. And so what we did is line up one end at 0 at the end of the aircraft, and then we would adjust the zoom level to give us the rough estimate about how far behind the aircraft we would need to deploy the sensor to get into that more stable air. And this is how we collected that information for the report. Next, I'll show you how I generate the traces, which is the little smoke streamers that I posted a video of. I don't know if many were able to see it just because of the large file size. So with this being uploaded to YouTube, hopefully more people will be able to get a look at that. So we're going to add traces. So we need to add the trace, but we have to put it in line of where we're trying to see. So we're trying to see the airflow. So we're going to need to go to the left side, which is the front of the aircraft. And we need to add, I've adjusted the density to 0.25. All this does is makes the density of the smoke traces smaller, so I get more in a smaller area, so you get more of an idea of what the airflow is doing. So you click and add, and then you click and you can see the dots forming, and drag. So now we have a bunch of little smoke rings that funnel down and interact with the aircraft. So with this, it's kind of hard to tell what's going on. So what I like to do is I edit the traces using the edit feature, and I'm going to change them from cylinders to lines. It makes it a little bit easier to see, and try to increase the width by 200. Makes them a little bit easier to follow, and this gives you an idea of kind of how the air is flowing, where air in the middle between features is being bent by the different pressures. Yeah, so this was just kind of a fun, kind of what you would think every CFD model does, because like when we see simulations ran with CFD, you like F1 car with the smoke going over it. This is kind of what that is representative of, and just kind of a fun tool. In our case, it actually is relevant in other use cases. As we had a already built model, we weren't trying to figure out where we're deficient in air flows. If we had issues with our design and started seeing vortices, we would start to see these lines start to curl, which would indicate that we would have to change our design. So that's where these traces would have come into play. But as it was, modeled off a real aircraft, so it's pretty stable. All right, and the last feature that I wanted to show was the wall calculator. This is one of the tools that I had the most issues with. I'll show you how to do it correctly, and then I'll go back through and show you what happens when you get a little complacent and don't click the right boxes, and you have to keep starting over. So here's the wall calculator. We need to add the volumes, which is the aircraft, the wind tunnel, and so we selected it, we imported all the volumes, but we need to get rid of the wind tunnel because that's not part of what we're trying to analyze. We're just looking at our model. So we're going to go deselect highlighted item, and we're going to deselect the volume of the wind tunnel. So now we see that we only have two volumes left. This would be the aircraft and the air volume bulkhead underneath the aircraft. So now that we've got that, we go to forces. We're going to have the output as newtons, and come down to torque and change that to Newton meters. And we are going to run the pressure as well in pascals. All right, so we hit calculate, and we get an output for each of the volumes and a summary of the overall. So this is what we're using to take our data for lift, drag, and similar in our crosswind calculations. We would look at the forces in the Fy, which is our axis perpendicular to flight, and the moment Y, as it would be the torque applied about the Y moment of the aircraft. So this would have been the force of the yaw caused by the crosswind. I'm not going to go into detail on that, but this is where we gather that data. All right, now that that's done, we're going to go back through and do the incorrect way. So if you get complacent in a rush and don't change from surface to volume, because everything in this simulation is a volume, there are no surfaces. If we go to select all, we're going to crash the program and we've got to start over. So here we go. And we get the insertion fail and abort, and it crashes. So that was one of the many frustrating things we had to work through and figure out what was causing it. There were several issues with just setting up the simulation, making sure that boundary conditions were correct. So, yeah, that's how we did our CFD simulations. And I hope you guys enjoyed seeing what we went through to get the data. All right. Thanks very much for watching. Bye.